Section 5.5.5 Multiple Angle Equations. This video is about solving multiple angle trigonometric equations. Double angle formulas. Sine 2u equals to 2 sine u cosine u, and cosine 2u has three different forms. Cosine 2u equal to cosine square u minus sine square u equal to cosine square u minus 1. Or 1 minus 2 sine square u, and tangent tu is equal to 2 tangent u or 1 minus tangent square u. So here's an example 1. Solve cosine 2x plus cosine x equal to 0. So let's see, this is our original equation, cosine 2x plus cosine x equal to 0. We cannot factor anything, so we have to replace cosine 2x using double angle formula, 2 cosine square x minus 1. So this equation becomes 2 cosine square x minus n plus cosine x equal to 0. Now it looks like a quadratic equation, cosine, so we rewrite this in order. So 2 cosine square x, and then we write plus cosine x minus 1. And now we factor 2 cosine square x, the factors are 2 cosine x and cosine x. And the factors are negative 1 would be plus 1 and minus 1. So now we have two factors, 2 cosine x minus 1 and cosine x plus 1. Let's set the first factor to 0, 2 cosine x minus 1 equal to 0. And then move the negative 1 to the right and divide by 2, so we have a cosine x equal to 1/2. And then we're going to solve this for x. So let's take the second factor set to 0. Cosine x plus 1 equal to 0. Move the 1 to the right, and we have a cosine x equal to minus 1. And now we're going to solve for x. So now we have a cosine x equal to 1/2 and cosine x equal to minus 1. So let's first solve cosine x equal to 1/2 for x. Well, it looks like 1/2 is greater than 0, and cosine x is greater than 0 in quadrant 1 and quadrant 4. So go to the unit circle and look for the ordered pair with the first coordinate 1/2, and that's this one here, 1/2 comma square root of 3 over 2. And then we have another one, 1/2 comma minus square root of 3 over 2. Now the first order pair 1/2 square root of 3 over 2 corresponds to this angle, pi over 3. And the 1/2 negative 1 square root of 3 over 2, which is this one, this corresponds to angle 5 pi over 3. So now we add 2 and pi into each of these angles. So we have x equal to pi over 3 plus 2 and pi, and then 5 pi over 3 plus 2 and pi. So we just found the cosine x equal to 1/2 as a solution, x equal to pi over 3 plus 2 and pi, and 5 pi over 3 plus 2 and pi. So now we look for solution of cosine x equal to minus 1. So let's look for ordered pair with first coordinate negative 1. And such ordered pair is this one, negative 1, 0. And negative 1, 0 corresponds to this angle, which is what? Pi. So now we add 2 and pi to pi to get x equal to pi plus 2 and pi. Now we list these two solutions, this solution in order. So I think pi over 3 plus 2 and pi smaller, and then pi plus 2 and pi is bigger, and then the last one is 5 pi over 3 plus 2 and pi. So here is an example 2. We're going to solve sine x plus sine 2x equal to 0. Again, we cannot factor, so we have to apply some kind of formula on sine 2x, and we do have a double angle formula, and sine 2x is 2 sine x cosine x. So we replace the sine 2x with this one, and the equation becomes sine x plus 2 sine x cosine x. Now you can notice we can factor sine x. and you're left with 1 plus 2 cosine x. Now we set each factor to 0. So let's set the first factor sine x equal to 0 and 1 plus second factor 1 plus 2 cosine x equal to 0. We can solve this one. You can move one to the right and divide by 2. So we cosine x equal to negative 1 over 2. Now we solve sine x equal to 0 and cosine x equal to negative 1 over 2 for x. So now we solve sine x equal to 0. We look for ordered pair with second coordinate 0 on the unit circle. So I think that's here 0, 1, 0 and negative 1, 0. And 1, 0 corresponds to angle 0, 2 pi, 4 pi, and so on. And the ordered pair negative 1, 0 corresponds to angle pi and 3 pi and 5 pi and so on. So now we can combine all this and put in order. So we can say x equal to 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. And we can condense into x equal to n pi, where n is 0, 1, 2, 3, and so on. We found that sine x equal to 0 has solution x equal to n pi. Now we solve cosine x equal to negative 1 over 2 for x. So we look for ordered pairs with first coordinate negative 1/2 on the unit circle. Such ordered pairs are negative 1/2 and square root of 3 over 2 and negative 1/2 and minus square root of 3 over 2. Now this ordered pair, which is this one, corresponds to this angle 2 pi over 3. And this ordered pair, which is this one, corresponds to this angle 4 pi over 3. So now we add 2n pi to x equal to 2 pi over 3 and x equal to 4 pi over 3, and we get x equal to 2 pi over 3 plus 2n pi and 4 pi over 3 plus 2n pi. Now we list this solution and this solution in order. So let's get this as small as we write 2 pi over 3 plus 2n pi, and the next is n pi, and then a comma, we list the 4 pi over 3 plus 2n pi. So here is an example 3, solving equation with half angle. So we find all solutions of the equation sine x over 2 plus cosine x equal to 1 in the interval 0 to 2 pi. So let's start with sine x over 2 plus cosine x equal to 1, and there is no way we can factor out. So this is a sine of half angle, so we can apply this formula. Sine u over 2 equals to square root of 1 minus cosine u over 2, with u is equal to x. So we replace sine x over 2 using this formula. So we write 1 minus cosine u we change to x, and divide by 2 square root, plus bring down cosine x equals to 1. Now this equation involves radical, so we need to get rid of this radical. So to do that, we will take everything to the right side and isolate the radical. So in this case, only I have to do is take the cosine x to the right side. So we have a square root of 1 minus cosine x over 2 equals to 1 minus cosine x. Now we square both sides. So when you square the radical, it becomes, radical disappears, and we get 1 minus cosine x over 2. But when you square 1 minus cosine x, you get 3 terms. Like 1 square is 1, minus cosine square is equal to cosine square. And the middle term is 2 times 1 times cosine x. So now we have a fraction on the left side. So we multiply both sides by 2 to get rid of fraction. So we have 2 times 1 minus cosine x over 2 equals to 2 times 1 minus 2 cosine x plus cosine square x. Now we can cancel out 2 with 2, gives you 1 minus cosine x distribute 2, 2 times 1 is 2, minus 2 times 2 cosine x, 4 cosine x, and plus 2 cosine square x. Move all the terms to the left side. So we'll have 1 minus cosine x minus 2 plus 4 cosine x minus 2 cosine square x equal to 0. Now we combine like terms and rewrite. So we have negative 2 cosine square x minus cosine x plus 4 cosine x gives 3 cosine x. 1 minus 2 gives you minus 1 and equal to 0. Now the square term is negative, so we multiply it by negative 1. So this will make it positive 2 cosine square x. This will become negative 3 cosine x. This will be plus 1. Now we can factor out, so it will be 2 cosine square x will be 2 cosine x times cosine x. And the minus 1 will be negative 1, negative 1. Now we set each factor to 0. So let's set first factor to 0. 2 cosine x minus 1 equal to 0. And we can move the 1 to the right, divide by 2, and we get cosine x equal to 1/2. That's called equation number 1. Now we set the second factor to 0, cosine x minus 1 equal to 0. Move 1 to the right, and we get cosine x equal to 1, and that's it. That is equation 2. So we have two equations, cosine x equal to 1/2 and cosine x equal to 1. So let's solve equation number first. Equation 1, cosine x equal to 1/2. In the unit circle, select look for ordered pairs with first coordinate 1/2. So first is that's the 1/2 square root of 3 over 2, and then another one, 1/2 minus square root of 3 over 2. Now 1/2 square root of 3 over 2 corresponds to angle pi over 3. And 1/2 minus square root of 3 over 2, which is this one, corresponds to angle pi over 5 pi over 3. So the x values are pi over 3 and 5 pi over 3. Now we solve the second equation, our equation to cosine x equals to 1. In the unit circle, look for an ordered pair of the first coordinate 1, and such ordered pair is 1, 0, and that's the only one here. And this corresponds to angle what? 0. So we combine all the x values, right, from the smallest to largest. So the x equal to 0 and pi over 3 and 5 pi over 3. So here is an example of 4. We're going to find all solutions of the equation cosine 4x minus cosine 2x equals 0 in the interval 0 to 2 pi. So let's start with cosine 4x minus cosine 2x equals 0. We can let u is equal to 4x and v is equal to 2x and write sum to product formula. Which is cosine u minus cosine v equals to minus 2 sine u plus v over 2 and sine u minus v over 2. We substitute 4x and v is equal to 2x. So this becomes cosine 4x minus cosine 2x equals to minus 2 sine 4x plus 2x over 2 and sine u 4x minus 2x over 2. We simply, this is already okay, this we can simplify. So it becomes negative 2 sine 6x over 2, and this becomes 4x minus x 2x over 2. And now we can further simplify, gives you negative 2 sine 3x sine x. But cosine 4x cosine 2x equal to what? 0. So this suggests that we can set this 0. So we have a negative 2 sine 3x sine x equal to 0. And now we divide by negative 2. So we get this sine 3x times sine x equal to 0. We set each trigonometric factor to 0. So we set the first factor to 0, sine 3x equal to 0, which is true when from the unit circle the angle is 3x equal to 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. And now we divide by 3, so x becomes 0 over 3, pi divided by 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. We can simplify and we have a x equal to 0, comma pi over 3, comma 2 pi over 3, pi, 4 pi over 3 and 5 pi over 3. So that's the solution set 1. Now we set second factor 0 sine equals 0, which is true when from the unit circle the angle is 0, pi, and so on. We combine 0 and 0 comma pi. Not 2 pi because we're looking for a solution between 0 and 2 pi. So we combine solution 1 and 2 and write in order without duplication. So the x equal to answer is 0 common and pi over 3 and 2 pi over 3 and then pi and then 4 pi over 3 and what 5 pi over 3.